Awesome. Thank you very much, Charlie. So yeah, first of all, thank you very much for inviting us to be part of the AECtech event this year. Obviously, we had hoped to do it in person, but online is I think the best we can do in these circumstances. So it's an absolute pleasure to be here. So yeah, I think Charlie gave a good summary of what we kind of want to discuss today. This title of Shifting Focus is really looking at how design technology firms and teams can actually move from focusing on project-based tasks to looking beyond that. How can innovation be applied on a daily basis and not just rely on us giving away our evenings and weekends tinkering around with tools? How can it become part of the everyday work? So this works. Okay, cool. Yeah, so introduction. Yeah, so this already happened. I am the Director of Design Technology here at Grimshaw, overseeing essentially all of our digital practices. And with me is Georgios Tsakiridis, who is our London Computational Design Manager, overseeing all things computation within our London studio. For those of you who don't know, Grimshaw, we are a global architectural practice. We focus on what tend to be large, complex projects, transport, aviation, and large-scale cultural buildings as well. And within that, we have our design technology team, which essentially covers all of our work relating to digital, whether it's BIM, computation, our work in VR and AR, as well as our explorations into emerging technologies as well. And we are a global outfit. We're not just based in one central hub feeding the other studios. We are distributed across our studios. So we have design technology teams in London, New York, Melbourne, and Sydney. And our team of about 30 to 35 specialists globally have this remit to really facilitate and enable our design teams. So the core role of our design technology team is to provide knowledge and to share knowledge. So we usually do that by embedding our design technology specialists within project teams, who can ultimately serve to identify opportunities for that knowledge sharing that we talked about, or feeding into our kind of critical mass of practice knowledge. So design technology to us, I mean, every practice has its own definition of this. To us, it's essentially all things digital and design related. So BIM, computation, extended reality are our bread and butter, let's say, with emerging areas around urban computation, our internal application development efforts, as well as data-driven insight, which is, as everyone knows, quite a hot topic at the moment. An important thing to mention as part of this is that we've very, very deliberately sought not to silo these specialisms off from one another. It's very easy to do that, and we've seen practices doing it, but we need all of our design technology specialists to be talking to one another, because BIM is becoming intrinsically linked with computational design, with extended reality. Application development sits across everything, as does data, and then urban computation is becoming much more relevant. So all of these specialisms, they need to speak to each other in order for there to be some appropriate level of knowledge sharing. We talk about interoperability a lot within the industry. To us, that's not just data, it's skills, it's knowledge, and that's fundamental to how we practice. So take for example, one project that some on the call, I think, a shout out to David Mans, who will know this intimately. This is the Dubai 2020 Expo Sustainability Pavilion, which is a project which has, we've supported on a huge spectrum of fronts, from complex modeling and the resolution of the design through very specific modeling practices, through to the use of computation to actually get feedback on design decisions. What implications does that have further down the line, as well as the initial design ideation itself? But that then feeds through, obviously, to the way that we document and deliver these buildings. There's a huge amount of interlinking of the processes to actually enable this. And that then feeds through into actually how we portray the design, visualization, whether it's CGI, whether it's working with our VR and AR teams. This project in particular was instrumental in helping us explore VR as a practice. And so that then brings us around to shifting focus, the title of this kind of piece. And to us, that shifting of focus is moving from just project support, just enabling design, to actually exploration of technologies, exploration of processes, and ultimately, how we can embrace that applied research, that applied innovation. And an example of that would be around VR and AR, as we mentioned. So 6 or 7 years ago, this is Sir Nicholas Grimshaw, our founder, when we were playing around with an initial Oculus Rift build. And then it's looking at how we can take that and make it part of our everyday process. So VR and AR has become fundamental in the practice. It's used by a huge amount of our teams. And so when I say that we're looking at shifting focus from project support through to applied research and applied innovation, that's not necessarily to say that the project support is diminished, but it's really to talk about how the latter can really enable the former, how they become fundamentally linked and become part of the everyday within the practice. And so, we can look at this idea of shifting focus through a few lenses here. One is looking at project enabling, as we've discussed, and I think as we're all familiar with, through to, that idea of applied innovation, how we can take one idea, one piece of inspiration and look at how it can become an everyday part of the Grimshaw design toolset. Through to, hardcore research, actually how we can be contributing to industry-wide research initiatives that, have the potential to have wide-ranging ramifications on the industry. So I'm going to talk to the first two there, the project enabling and the applied innovation. And then I'm going to hand over to Georgios, who's going to talk through a pretty fundamental research project that we've been very lucky to be part of and are quite excited about at the moment. So this idea of applied innovation, of project enabling, again, we're trying to look at that through the lens of innovation, how we can use the latest technologies, the latest developments within the industry. In this case, it was the amazing work that McNeil output around Rhino Inside, which has now become, the everyday for us. It's how we enable projects on an everyday basis. Rhino Inside is, kind of a gift to us in that sense. But then looking through to, other projects, how we can spot a nugget of, kind of key work that we keep undertaking on a project and look at how we can build our own tools, our own innovations around that. So take, for example, master planning projects. I'm sure there's a lot of people on the call who can sympathize with having to undertake the same processes again and again on a project, whether it's environmental studies, whether it's, linking parametric models through to spreadsheets, whether it's scheduling, whether it's cost data. This is something that I'm sure a lot of people can sympathize with. But what we've done is we've started to take some of those processes and build our own tools around them. So in this case, this is one that Georgios Sands, who's our urban computation lead, has been looking at around how we can take open source mapping data and actually start to use this on the base of every urban project that we have. This is extracting fundamental information, but if we can do this at the beginning through an automated computation-driven way, it then makes the rest of the process much, much easier, which is a fundamental tenet of what we do within design technology. We essentially enable designers to design, so we take away the painful points. But that then feeds through into how we document and how we describe our projects to our clients. Can we make interfaces which allow them to explore designs without having to scroll through reports, without having to scroll through reams and reams of project data? We can just make it available for them at the touch of a button, with also then some potential for some optioneering within that interface. And then from that, as I said, we tend to work across large-scale complex projects. So some of our more geometry-driven things might not be as useful, but there are certain processes that become, that come through on a repetitive basis. Take, for instance, pedestrian flow. We're not pedestrian flow engineers. However, it's fundamental to a lot of the projects we undertake. So building an interface that allows us to explore this, on that design-based iterative frequency was a fundamental thing for us to undertake. But what that then means is that we can build it into the way that we work on these projects. Actually, not just making it accessible for design technology specialists, but potentially making it accessible for our designers. You know, if the interface is good enough, then they can jump on board with it. And so, you know, this idea of applied innovation is something that we're quite excited about, and this idea of democratizing technology beyond just, you know, a design technology team, but making it accessible to our designers is really fundamental in that sense. And then, you know, looking to the future, what do we want to look at in terms of other applied innovation? You know, this is a bit of behind the scenes of stuff that we're starting to get excited about. You know, can we be describing master planning projects based on existing project data? Can we start, you know, then tying that in with some more machine learning driven environmental processes, so we're not having to run long computational processes on the fly. And so with that said, I'm now going to hand over to Georgios, who's going to go through one of our research projects. We're just going to do a quick changeover whilst he starts sharing his screen.
Thank you, Andy. And now we'll try to do a seamless stitching of the two parts of our presentation. Let me know if you can see my screen.
Yep.
Right, so let me just reiterate that it's an absolute pleasure to be with you. AECtech is a point of reference for the industry. It's a real honor basically to be here presenting today. So I will be talking about this specific research initiative that we were very happy and lucky to find ourselves being part of, the Construction Innovation Hub, which at its core basically is about DFMA, so design for manufacture and assembly processes, and offsite manufacturing, right? Right. Now, in a way, DFMA and offsite has been at the core of Grimshaw's DNA. We can take it all the way back to the innovative and pioneering work that Nicholas Grimshaw did, you know, all the way back to the 70s. But also looking at how we pursue these sort of approaches today with projects like the Crossrail over here in London, UK. So in a way, it's a very exciting topic for us. And we're always keen to not only follow up the developments of the rest of the industry, but potentially be able to drive some of these fundamental discussions if you want. One of the key aspects of making DFMA and offsite manufacturing possible today and successful is that there is a general understanding that there needs to be a fundamental digital infrastructure to enable it. So as part of the Construction Innovation Hub, which basically is a research initiative driven by the UK government, which fundamentally is looking after a standardized kit of parts in order to deliver social infrastructure at scale. There is a fundamental piece of software typology, let's say, which as well is very popular in the industry these days, that of the configurator, right? So as part of a very complex hub of organizations and stakeholders involved and parallel work streams, it's worth mentioning that there are at least 5 government departments involved on the, let's say, client side of this project, including the Ministry of Housing, the Ministry of Justice, the Ministry of Defense, the Department of Education, and the Department of Health and Social Care. And on the other side, we've got a very large group of what one would call the leaders, let's say, of the UK AEC industry across all scales and all levels. So in a way, it gives us a very good understanding of what the industry is capable at the moment. And we were very happy to find ourselves as Grimshaw and with our counterparts, Bureau Happold engineers, leading the digital work stream of the hub. And in particular, what we'll be talking about today is the work on the digital configurator. Now, worth mentioning that this has been, as I said, a very important collaborative process for us. And as Andy was saying, that we're trying to take down the silos between the different parts of the design technology and our design teams it's definitely within the ethos of design technology to try to take down the boundaries of the different disciplines as well. So we consider it as an ultimate multidisciplinary effort. We're very lucky to have to be partnering with Dr. Al Fisher, Director and Head of Computational Design at Bureau Happold, Alessio Lombardi, Computational Design Specialist at Bureau Happold, and from our side, Andy, myself, and of course, Justina Szyczowska and Natalia Wojtowicz are city specialists. So before I even start talking about why, what is a configurator and what is the common configurator framework that we're providing, I think it's worth asking what is a configurator and why do we even need one? And in a way, a typical example of what is of what people consider a configurator outside of our industry is this sort of, this is an example of the Tesla, right? The Model X configurator. And this describes a world in which the user visits a web page and is able to configure, you know, the ideal version of the product that you want. In this case, it's, you know, it's the color of your car, the wheel trims, the autopilot package. And in general, it's a world where the end user is able to customize, the end user is actually able to customize and configure the product. So it's a very neat, a very compelling and a very clear idea, which I think has been, you know, within the AEC for some time now. We do know, of course, that our industry is quite different, right? And things are a bit more complex than that. We know that AEC is decentralized, it's fragmented. For once, we're definitely not delivering one product, and probably for good reasons. There are multiple designers collaborating from early to late stages. There are hundreds of manufacturers and fabricators trying to collaborate, different supply chain integrators. And at the same time, of course, today, we can see this rich ecosystem of configurators emerging across the industry. Because we obviously all see the potential of following such a paradigm. So the question for us is not if we are supposed to be following that, but actually how do we do that at scale? And this is the question in a way that we tried to answer within the Construction Innovation Hub. So early on, as part of the main themes that emerged through this user requirements journey that we took with the stakeholders, was that it's probably the assumption there is no one good configurator, there is no one silver bullet, let's say, that can satisfy all of these complex user requirements. And that it would be a much more fruitful path if we start thinking along the lines of facilitating a framework, if you want, that allows for multiple configurators actually to coexist. So multiple configurators to be built and to be able to talk to each other, configurators across multiple organizations, multiple disciplines. So the fundamental part in order for this to work was for us to enable this communication between the configurators so that we allow the fundamental data exchange, but also to increase the compatibility between the widest range of software typologies, from plugins to standalone apps to web-based platforms and everything we see emerging in the industry. So we sort of came up with these four core, let's say, principles of our common configurator framework, which is first of all, the interoperability between them, which is quite obvious, the composability of the exchange data that the configurators work, the extensibility, if you want, of their objects and their functionality. Again, these are quite obvious within the latest developments, let's say, of the AEC industry, but fundamentally, and this is the little piece of novelty, if you see, that we're sort of adding here, the design verification through a common object specifications. So before we dive into more details, I'd like to quickly have an understanding of what we consider as a configurator. And this is a very good diagram that describes this. For us, fundamentally, it's a flow of information from left to right. So we've got inputs, we've got the actual configurator, the computational bit, and outputs. So at the core, we've got what we call the script. And the script, as I said, has this basic computation. And of course, we can understand that it has inputs that need to be fed in. There are outputs that have to come out. But within this framework, obviously these inputs, they have to come outside of the configurator, and therefore the outputs have to end up outside of it. So this computation does not exist, if you want, in isolation. The other important bits to remember is the user interface and the graphical view, which sort of separates it from typical, let's say, configuration, other sort of, let's say, computational applications, which of course allow for the users to configure the inner workings. So if we start thinking of how these configurators could work within this framework, we can see here a diagram of all the players. We've got the users interacting with the configurators, we've got objects and their object specifications as they come from repositories flowing into the configurators and working off the clue to this whole framework, which is this common object schema. Now, for the framework, the important key take is that we are not proposing a fixed common object schema. The framework is actually agnostic to that. But one should imagine that in order to enable the collaboration, a schema has to be agreed in advance so that objects and their object specifications are actually compatible to each other. So if we continue looking at some of the key concepts, let's say, that are part of the configuration, first of all, it's all about passing around objects and objects in that very sort of object-oriented understanding that we have, right? So object instances, and I think we're at a point where our industry has been accustomed very well with the concept of object-oriented thinking, like building information, within building information modeling, etc. So it's all about how we're passing around data and sort of as individual structured objects. The other important bit here is their object specifications. And these are actually encoded rules against the objects. So in that question of how do we actually process verification and validation through object specification, our proposal is this very simple logic that says that an object spec is nothing but a filter condition, which actually selects the objects that you need to write a specification for or write a rule for. And there is a check condition that actually kind of specifies what is the rule you're catering for. Now we have to imagine that we have applied this into this kind of hierarchical structure of a system where we start from the building, which is the assemblage of all of the assemblies and parts, all the way down to the individual parts. And these object specifications within the framework we are able to apply them at any of these levels. And for those of us that are more familiar with systems engineering, we can see that this logic gets very nicely coupled with this sort of a hierarchical, methodical, iterative process of the V diagram of system engineering that allows to apply specifications and therefore check objects against them in this methodical, hierarchical way. Now, ultimately here, we've got an example of how this comes into play. So on the left, you see here the object specifications that we create, and we can imagine them living all in these kits of rules. And on the right, we've got the kits of parts. At the center, we've got this fundamental concept of what we call coordinated zone specifications, which allows for this powerful decoupling, if you wish, of the requirements of the design from the actual parts that constitute the design. So since we're speculating about the fact that we don't have one configurator, we can start thinking of at least two teams of configurators. The one is the design configurators, and actually we should imagine them as a chain of configurators, which are there to organize objects specifications into coordinated zones. And on the other side, we've got part configurators, where we can imagine the individual manufacturers, product owners, etc. They can come in and they can test their objects against those coordinated zones. So this is a diagram here that shows like this sort of neat ideal scenario of how we could map any of these different examples across our project. But of course, as we said, we know that the AC industry and the design process is actually rather non-linear. It's very messy and it's complicated. So this is a diagram here that showcases our reference implementation, because apart from the theoretical, if you want, thinking, we actually proceeded with a reference implementation. A reference implementation, which we looked into actually developing a series of prototypical configurators that have the capacity to pass data between one another, validate data, and in a way work as an example. All this is open source. It's publicly available. There's a series of reports that we're gonna also make publicly available. This research is ongoing. We definitely want to encourage conversations around these efforts, and would be very happy to receive your feedback. And with that, I'm gonna finish here. Thank you very much.